Okay, good morning. We're going to continue our discussion of permutations real quick. I want to ask, how many permutations are there of the letters in the word math, M-A-T-H? So basically I want to know how many different ways can I rearrange M-A-T and H to make a new word. Now in mathematics, a word is any combination of letters. So for example, M-A-T-H is one word and A-M-T-H is another word. Even though AMTH isn't really in the dictionary, in mathematics, AMTH would be a different word because they are in two completely unique and different ones. So basically, I have 1, 2, 3, 4 spots, and I need 1, 2, 3, 4 letters. So like we did yesterday, that's going to be a permutation. I have 4 available letters, 1, 2, 3, 4, and I have 4 places I'm using. That's a permutation of 4 choose 4. So, as those previous examples, that's going to be 4 factorial over, 4 minus 4 factorial, which is really 4 factorial over 0 factorial. Now, we haven't talked about this quite enough, but we have defined it in some earlier notes that 0 factorial is always 1, and that's based off of patterns. So, not going to go into details on that, but I invite you to look that up and see why the patterns of 0 factorial would be 1. Just take a 5 factorial, 4 factorial, 3, 2, 1 factorial. Just work it down and you'll see why 0 factorial has to be a 1. So in this case, that's 4 factorial over 1, which is of course 4 times 3 times 2 times 1, or 24. All right. So that leads to an interesting discussion. We hadn't talked about it earlier. Notice 4p4. Why is 4p4 the same? Do you notice that 4p4 is the same as just 4 factorial? It's because of this 1. So anytime that we have 4 items available and we're going to choose all 4 items, it's really just a factorial. Okay, it could be 5p5 or 7p7 or 10p10. It's just going to be that factorial. So now we look at a new situation here, again with letters. How many permutations of the letters, or words I should say, in the word letters, L-E-T-T-E-R-S. As we did before, remember, it's any combination of those, combination is the wrong word, any arrangement of these will create a word in mathematics. So L-T-T-E-E-R-S would be a word, even though it's not in our dictionary. So I do have a permutation, and I've got 1, 2, 3, 4, 5, 6, 7. I have 7 available letters, and I'm going to use all 7. And we just talked about the fact that 7p7 or 4p4 or whatever is going to be 7 factorial. However, let's take a moment to talk about this real quick. L-T-T-E-E-R-S, is that the same or different word as L-T-T-E-E-R-S? What do you think? Do you think those are the same or different? Well, the way they look right now, they look absolutely identical, don't they? Okay, but remember, I actually have 2 T's. I don't know which T is first and which T is second here. And the same thing with my E's. I don't know which E is first and which E is second. So they're really hard to distinguish the difference. So what we have to do is we have to realize that these are really the same. And, maybe these two just switched. So how many ways can you switch those? Here's what we have to do. We have to divide out all of the repetition. So we're going to divide the repetition. We're going to divide out the repetition. So what repeats? Let's see. I have the letter E that repeats twice. So I'm going to divide out 2 factorial, because that's how many ways I could rearrange the letter E. But I also have the letter T. So I have 2 T's, so I'm going to do 2 factorial there. Now, if I would have had 3 letter E's, I would have done 3 factorial. Or if I would have had 4 letter R's, I would have done 4 factorial. So since I had 2 E's, I did 2 factorial, and 2 T's, I have 2 factorial as well. So I'm going to divide this out. On this one, I think it's just going to be easier just to multiply it out. So 7 factorial is 5040. 2 factorial is 2 times 1, that's a 2. Another 2 times 2 is, that's actually a 4, right? So 5040 divided by 4 is going to give us 1260.